Business Calculus, Topic 7.4. Find the location of the minimum, maximum, and inflection points. Okay, of this function. Let's graph this function, kind of get a good look at it. Open parenthesis, x squared minus 1, close parenthesis, then division, open parenthesis, x squared plus 1, close parenthesis. Then we'll graph it. Okay, now this graph, you can kind of see that there's a minimum right here. That's probably closer to 0 right here. Looks like we have a couple inflection points, one on the left and one on the right, where the concavity changes. This is concave down, and this is concave up. So there's a change there. This looks concave down. This looks concave up, and this is concave down. So it's probably an inflection point somewhere in there too. So we're looking for maybe one min and two inflection points. So let's go after the min first by taking derivatives. I'll take a derivative of this. So a derivative would be using the quotient rule. X squared plus 1, x squared plus 1, x squared plus 1, then x squared minus 1 minus x squared minus 1, a derivative here, here, and a square there. The derivative of x squared minus 1 would be 2x, and the derivative of x squared plus 1 would be 2x. So using the 2x, we're going to distribute it. We're going to get 2x cubed plus 2x. The negative and the 2x, when distributed across the x squared minus 1, we'll get a negative 2x cubed and a plus 2x. And everything's over x squared plus 1 all squared. Okay, now from here, we're going to collect like terms. These cancel, and we're left with 4x all over x squared plus 1 all squared. Okay, in order to find out where the derivative is 0, or it's our rational function, we simply use the numerator. So this would be 4x set equal to 0 and x equals 0. And this is going to be so you have a min at x equals 0. And that kind of matches with what the graph looks like. Okay, now hunting down the inflection points. Okay, we need to take a second derivative. So let's begin. A second derivative we have x squared plus 1 will all squared and squared again, which is to the fourth. So x squared plus 1 squared, and then the 4x minus the 4x, and then the x squared plus 1 all squared. Okay, and we'll have a derivative on this one and this one. Okay, a derivative on 4x just gives us 4. That's pretty easy. But we're going to use chain rule for this one. The derivative of the x squared plus 1 all squared is going to be 2 times x squared plus 1 to the first power, then times the chain rule, which will be times 2x. Alright, so let's put all that together. The 4, we're just going to put in front of here. So 4 times x squared plus 1 all squared. On the outside, we have a 4x, a 2, and a 2x. When we multiply all that together, we're going to have 16, so minus 16, x to the second power, and what remains here is x squared plus 1 all squared over x squared plus 1 to the fourth. Okay, again, when setting this equal to 0, all we're concerned about is the numerator being set equal to 0. So let's just remove the numerator. 4 times x squared plus 1 minus 16x squared and the x squared plus 1 all squared set equal to 0. Alright, now solving for that x. I'm going to try doing this. I'm going to take out that the x squared plus 1 out of here. Oh, I've got my little square. Okay, and I want to make sure I haven't lost anything. Oh, that 2 right there should be a 1. Okay. Alright, so it's back down where it should be. I gained a 2 and lost a 1. Okay, now let's take out the x squared plus 1 out of both. Oh, we can also take out a 4 as well. So 4 and the x squared plus 1. And that leaves behind the x squared plus 1 to the first power minus 4x squared. Now that all equals 0. Okay, let's start kind of cleaning this up in here. So 4x squared plus 1. And inside we'll get, let's see, I'll take the negative. No, I don't have to take a negative out. So 4x squared. Added to the x squared here, that'll be negative 3x squared. And plus 1 equals 0. Alright, this one cannot be factored, cannot be solved for 0, so we're going to ignore that guy. This one can solve for 0. So we're going to take some time out to find out what is negative 3x squared plus 1 equal to 0. I'm going to put the 1 on the other side, so we'll get negative 3x squared equals negative 1. Divide everything by negative 3, and we get x squared equals 1/3. Okay. From there, I'll take the square root of both sides, and I'll get x equals plus or minus the square root of 1/3. Okay, and that represents the points on both sides here. On this side here, we got the square root of 1/3 right here in the inflection point, and we have another inflection point here at the positive square root of 1/3. So there's inflection points at x equals the negative square root of 1/3 and x equals the positive square root of 1/3.